So yesterday we started talking about triangle proof, okay? How we prove triangles congruent, writing triangle proof, okay? And I explained that writing a triangle proof is how we mentally were able to identify corresponding parts in two triangles to determine if the two triangles were congruent to each other, okay? Or are congruent to each other. So we're going to extend that today and talk about how we write proof to prove that two triangles are congruent to each other so that we can prove that a pair of corresponding angles or corresponding sides are also congruent to each other. So we talked about in our opener this morning, the 5 ways the triangles can be congruent to each other, okay? We talked about side by side, where we have 3 sets of congruent and corresponding sides that are congruent, okay? We talked about side angle side, where you have a set of corresponding and congruent sides, a set of corresponding and congruent angles, and then another set of corresponding and congruent sides, okay? But remember, with side angle side, the angle has to be included, AKA it means it has to be between your 2 sets of congruent and corresponding sides. We talked about hypotenuse legs, okay, which specifically deals with right triangles. And we have to have one set of legs, and the hypotenuse in each triangle congruent in order for it to be HL. Okay, remember, we emphasize the fact that HL only pertains to right triangles, okay? But do not be confused. Just because a set of triangles are right triangles does not automatically mean that those 2 triangles are congruent to each other via hypotenuse leg. Okay, remember, the H in HL is hypotenuse. If the hypotenuse on your 2 triangles are not marked, then that means that those 2 right triangles are not congruent to each other via HL. Okay, angle side angle. We have 2 sets of congruent and corresponding angles with a side that is in between the 2 angles, okay? And then angle side, where we have 2 sets of congruent and corresponding angles, and the side is non-included or outside of the 2 angles. Y'all remember, there are only 5 ways that we can prove triangles congruent. If it's not one of these 5 ways, then that just means those 2 triangles are not congruent, okay? What I also noticed on the quiz is, y'all, just like I clip, every time I click the slide, it marks the figures. What I noticed is that some of y'all weren't able to come to the correct conclusion because you did not mark your figures. When you're trying to prove triangles congruent, you have to mark your figures, okay? If they share a common side, you need to mark that because that's something that's shared. If they crisscross and it looks like a bow tie or a fish or an hourglass, you know, you have a set of vertical angles. You need to mark that as well because that's inferred. Those are the only 2 things that are inferred: vertical angles and a shared side. Other than that, you can't. Some of y'all try to make triangles that appear to be right triangles, okay? Look at all these diagrams. They all look like halves of right triangle. Y'all, there's nothing marked on this triangle, this triangle, this triangle, or this triangle that indicates that those are right triangles. It does not matter that they look like a right triangle, okay? We absolutely know that the one that represents HL is a right triangle because you see the box in the corner, okay? All right, so now that we know how 2 triangles can be congruent to each other, okay, let's see what we can say or what we can do to help push us along to the proofs process, okay? Now, look at your figure, okay? Tell me what you see marked on your diagram. What parts do you see marked? Angles and sides is what I mean when I say parts. Y'all, I know y'all don't have the diagram on your page. It's only on my slide. I know that goes through. So y'all tell me what you see based on what you see in your diagram. Okay. Okay, side AC is congruent to side AC. Okay, how do you know that? What would be your reason? If we were writing the proof, how would we know AC is congruent to AC? What property? Y'all don't guess, go back and look at your notes from yesterday. You have all your reasons on there. Where we see a midpoint? Thank you, it's reflexive property. Y'all, the midpoint cuts a side into, or a line segment into two equal segments. That doesn't have anything to do with the midpoint. Please be careful, okay? What else do you see in the diagram? Can you just call it angle A since it's in two separate triangles?
Angle AB.
Put A in the middle.
Angle BA.
Good. It's already marked on the diagram. So how do you? Good, it's given. It's already marked on the diagram, so it's given. Y'all, anytime information is marked on a diagram, that means that information is given. Okay. So we got these two angles right here. Okay. Tell me what else you see. Somebody starting to say angle. Angle what? Don't guess. Y'all, look what you see on the diagram. Remember, you can't just call it angle C because it's in two separate triangles. Look, here's angle CAB. CAB. So be careful. Yeah, the letter should be in the middle. How you deal? Yes. Thank you. You said BCA. Is that what you said? Okay, good. Angle BCA is congruent to angle what? Good. It's labeled on your diagram, so it's given. Okay. Y'all look. How do we prove that these two triangles are congruent to each other? Via what?
No, angle side.
Good. We know that triangle, I'm gonna call them triangle ABC, is congruent to triangle. Y'all look, if I call this first triangle ABC, what do I have to call the second triangle? What you say? I look ABC. Y'all look. Look, ABC. So what is good? It has to be ABC. Because remember, your corresponding angles and corresponding sides have to line up. Okay. And what did you say? By what? Good. Angle, side, angle. Okay. That's it. Y'all, we condensed the proof writing process But that's it in a nutshell, okay? Y'all look, we have two sets of congruent angles that are congruent and correspond. We have a side that's in between those two sets of congruent and corresponding angles. So we know that these two triangles are congruent to each other via angle side angle, okay? All right, so what CPCTC says, or what it means. Go back to what other page? Yeah, y'all may practice some from there. Well, I have a sheet that y'all are gonna do for grade later, but just hold on to it because y'all can use that to review your test. Okay, so CPCTC means corresponding parts of congruent triangles are congruent. Okay, what that means in a lot less words is this: if we can prove that two triangles are congruent to each other, then we can prove corresponding parts that are not marked, angles or sides that are not already marked. We can prove that those two angles or two sides are congruent to each other, although it's not marked on a diagram or given to us in the proof, okay? That's all CPCTC means, okay? It helps us prove that a set of sides, of congruent sides, are in a congruent triangle, okay? But the key is we have to prove that the two triangles are congruent first in order to prove that the two sides or two angles are congruent to each other. Okay, that's CPCTC in a nutshell. All right, y'all, in order to prove two parts of a triangle congruent to each other, okay, we have to first prove how the triangle is congruent to the other triangle, okay? We know our 5 ways that we prove triangles are congruent. You have to prove that the two triangles are congruent before you can prove that those two sides for CPCTC are congruent to each other, because those sides are not going to be marked in your diagram, okay? So looking at these two triangles, okay, we want to figure out first how these two triangles are congruent to each other so that we can then prove that side RT is congruent to side LN, okay? Y'all look at your diagram. Side RT is not marked, side LN is not marked. So right now we don't know anything about those two parts of the triangle, okay? But if we prove that those two triangles are congruent to each other, then we'll automatically know that side RT is congruent to LN. We just have to prove that those two triangles are congruent to each other first, okay? Y'all look at these two triangles, okay? Let's identify our corresponding parts first. Y'all look at the triangle and tell me what your corresponding parts are that you see marked. Angle what is congruent to angle what? Side what is congruent to side what? Uh-huh. Good. It's some. Hold on. Is somebody behind me snoring? I thought somebody was behind me was snoring. You said angle what is congruent to angle what? Good. Angle S is congruent and corresponds to angle M. Okay, tell me what else y'all see. Okay. Angle P is congruent and corresponds to angle L. Okay, do y'all see anything else? Uh-huh. Okay, look, you called it SR. So look, start at the 90-degree angle, then go down. Uh-huh. It's congruent and corresponds to MN. Okay. Y'all look at the triangles. If it helps you to mark them with A and S, do so. Okay. Look. Angle, 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 side, side. Okay. So how are these two triangles congruent to each other? Okay, angle, angle, side. Y'all, we proved the two triangles are congruent to each other, okay? Now that we know these two triangles are congruent to each other via angle, angle, side, we can say that side RT is congruent to side LN by CPCTC, okay? Ms. Grubb, why can't we go straight to CPCTC when we're trying to prove that two sides or two angles are congruent to each other? Because you have to prove that the two triangles are congruent to each other first, okay? Y'all, you cannot use CPCTC until you figure out how those two triangles are congruent to each other, okay? Because if so happen the two triangles aren't congruent to each other, that means those two sides or two angles can't possibly be congruent to each other, okay? Question. Because it's asking us to prove that side RT is congruent to LN. We're not proving that the two triangles. Okay, let me re-explain this, try to explain this a different way, okay? Yesterday, we just worked on proving two triangles congruent. That's it. We were trying to prove whether triangle ABC was congruent to triangle DEF. Okay, that's it. We were just trying to prove two triangles were congruent. Okay, today, we're learning how to excuse me, prove two sides or two angles are congruent to each other. But in order to do so, we have to first prove that those two triangles are congruent. Because this angle, the angles and the sides that they give you to prove are congruent, it's not going to be marked on your diagram and it's not going to be given in your given statement. Mm-hmm. Yep. All right. So look, y'all, this time we're trying to prove that line segment EF is congruent to line segment KJ, okay, or side KJ. Y'all look, it's not marked. Just because you see it right here does not mean you mark it. This is what we're trying to prove to be true. We just have to prove how these two triangles are congruent to each other first. Good, you have to mark your vertical angle. Okay, we have to mark the vertical angle first. All right. F what? Uh-huh. Good, JD. Hold on. Okay, look. FD is congruent to JD. What else? ED, uh-huh. Uh-huh. ED is congruent to KD. And what's the last thing? Y'all look, how many places do you see angle D? In how many different triangles? 2. So can you just call it angle D? Y'all look, when you name it using 3 letters, always put the name of the angle in the middle. In the middle. Okay, hold on. I heard EDF first. So angle EDF. Y'all said EDF and KDJ. Okay. Y'all, how do we just prove that these two triangles are congruent to each other? Look at your diagrams, mark side and angle if you need to. Side what? Good. Look, side, angle, side, side, angle, side. Okay. So side, angle, side. Y'all, now that we know these two triangles are congruent to each other, how do we just prove that side EF is indeed congruent to side KJ? If the two triangles are congruent to each other, by what? No, that's how your two triangles are congruent to each other. How do we? Y'all listen to my question. We just proved that triangle EDF is congruent to triangle KDJ. Okay, look, we know that to be true. But look, now that we know that these two triangles are congruent to each other, how do we know that unmarked side EF is congruent to unmarked side KJ? Good. It's CPCTC, okay? Y'all look, I'm gonna go a little bit backwards, okay? If I call the first triangle FDE, okay? Y'all, I called it FDE. What has to be the name of the second triangle if I call the first one FDE? JDK. Okay, remember, it has to follow the pattern. Y'all questions? Y'all, that's all you're doing with CPCTC, okay? You're identifying your corresponding parts to help you prove how the two triangles are congruent. And since we're trying to prove that side EF is congruent to side KJ, y'all, again, when you're trying to prove a set of sides or a set of angles are congruent to each other, you have to prove that the two triangles are congruent to each other first. And then you use CPCTC as your reason. Because now that you know that the two triangles are congruent, you know all of the corresponding angles and sides are also congruent, okay? So we're just taking it a step further. Yesterday, we just proved that triangles were congruent. Today, we're proving that triangles are congruent so that we can then in turn prove that parts of the triangle are congruent, that we don't have any information about, okay? Y'all look, you see two sets of parallel lines, okay? Anytime you see parallel lines, you automatically know that one of your reasons, or you're able to identify in your diagram that you have what types of angles. Not right, look, this is slanted. Y'all look back at your notes and see what it says about what happens when you see parallel lines. What types of angles do you see? Say it one more time, sweetie. Good. Y'all, anytime you see parallel lines, you automatically know that you have alternate interior angles, okay? Look, here are your parallel lines, and here is the transversal, okay? Y'all, I'm gonna show you this one. I'm gonna show you the markings on this one, and then I'm gonna let you mark your own, okay? Y'all look, these two angles are congruent to each other. Why, Ms. Grubbs? Y'all look, they're between the parallel lines, but on opposite sides of the transversal, which tells you that they're alternate interior, okay? Ms. Grubbs, how many sets of parallel lines do you see? Y'all look. Oh. Look, 1, 2. Do you have another set of parallel lines? Yes, on the sides. Y'all, if you have parallel lines on the top, a set on the top and a set on the side, all that means is you have two different sets of alternate interior angles, okay? Y'all, I'm gonna let this slide mark it for you so it's easy. Okay. That's where they are. They're right there in the middle on both sides. Okay. Y'all, what isn't marked yet that needs to be marked? Good. Okay. Now, y'all, I'm not gonna list all of the corresponding parts right now because you should be able to see how these two triangles are congruent to each other. Okay. Y'all tell me how these two triangles are congruent to each other. Kick up. Good. Angle, side, angle. Okay. Here's the visual if you need to see it. Y'all, I'm just gonna put A and S on your corresponding part so you can see it. Angle, side, angle, angle, side, angle. Okay. So since we know that these two triangles are congruent to each other via angle, side, angle, how are we able to prove that side XY is also congruent to side ZW? Good. We're able to prove that those two sides are congruent to each other via CPCTC. Okay. Y'all, and there's your statement. Okay, I think y'all got the gist of how to name the triangles once you get the statement. Y'all, questions? All right. Y'all, we're trying to prove that angle C is congruent to angle F. But remember, we have to prove how triangle ABC is congruent to triangle DEF first. Okay? Y'all, what type of triangles do you see? Right, okay? So what could be a possible way that those two triangles are congruent to each other? It could possibly be HL. Y'all, if you think the two triangles are congruent to each other via HL, where do you need to look for markings? Okay, the L does stand for legs, but what does the H stand for? Good, so you have to look to see that a set of legs are marked congruent, and you have to look to see if your hypotenuse are marked congruent, okay? Y'all look, what's the name of the side that represents the hypotenuse in each triangle? What's the name of the side though that represents the hypotenuse? What's the hypotenuse in this triangle? Good, AC, what's the hypotenuse in this triangle? Are both of them marked with the same type of tick mark? Yeah. Okay, so we identify the hypotenuse. Y'all, side AB, is that a leg? Does it correspond and is it congruent to side DE? Yeah. So how are these two right triangles congruent to each other? Good, HL. So since we know that these two triangles are congruent to each other via HL, how are we able to prove that angle C is in fact congruent to angle F? Good, CPCTC. Okay, y'all, I forgot how I listed the triangles on this slide. Okay, but if I call this first triangle CAB, what has to be the name of the second triangle? Good, FDE. I probably said ABC and EDF. I did, it's a habit. Okay, but Ms. Grubbs, that congruent statement is different than the one that we said. Doesn't matter, the corresponding angles and sides still line up. Okay, y'all, good job. Okay, here's some hints on proof just to refresh you from yesterday. Okay, y'all look, y'all gonna help me fill this in because y'all should remember from yesterday. Okay, if two triangles share a side, then you will probably use which property? Good, reflexive property. Okay. If two triangles share a side, then you will use the reflexive property. Y'all, 9.99 times out of 10, you're going to use your reason is going to be the reflexive property. Ms. Grubbs, why didn't you say always? Y'all, I will rarely ever say always because it's always going to be a case that proves you wrong when you say always. Okay? And y'all, that's an example of the reflexive property. You don't have to draw the examples because you got examples in your notes yesterday. Okay, if you have vertical angles, what's going to be your reason? Good, our vertical angles are congruent. Okay. All right. And there's your sample of your vertical angles. Again, y'all do not have to redraw these because you drew them yesterday. Okay. If you're given the word midpoint, what are you going to use to describe that? The definition of a midpoint. Y'all, if you see the word bisect, what two things do you bisect? Segment, and what's the other one? Good. Okay, if you see the word midpoint, one of your reasons is going to be definition of midpoint. Okay, if you see the word bisect, you're either going to use definition of a segment bisector or a definition of an angle bisector. Okay, Ms. Girls, how will I know to use segment bisector or angle bisector? Because it's going to specifically tell you side EF bisects side BC. Side DF bisects angle B or angle BAC, okay? So that's how you know if you're using segment bisector, definition of segment bisector, or definition of angle bisector. Okay? Y'all, if you're given two parallel lines, then what types of angles do you know that you'll have? Y'all look, parallel lines, and remember, a diagonal is always gonna create a triangle. Good. Alternate interior angles, okay? Y'all, anytime you see parallel lines, y'all, the easiest way to find your alternate interior angles, okay? A lot of times, most of the time, your diagram is gonna look like a Z, okay? It's gonna look like a Z. Here are your two parallel lines. Y'all do copy this little diagram that I'm drawing right now down, okay? Y'all, that's supposed to be a triangle up top to denote that that's a parallel line, but y'all know I draw crooked sometimes, okay? Y'all look for the Z, okay? Ms. Grubb, conceptually, I'm not understanding. Okay, let me make some badly drawn sides to connect this. Okay, there you go. You can tell. You got the two parallel lines on top and bottom because you have the arrow, okay? The diagonal is what creates the transversal. Y'all look for the Z to figure out where your two sets of alternate interior angles are, okay? Y'all, it's always gonna be a set there on this side of the Z, and then it's always gonna be a set on the top on the opposite side, okay? Look for the Z. Y'all, question. Y'all, I'm really pleased. Y'all are doing really well with the proofs. Really well. Oh, I did have a diagram up there. All right. Y'all, if you're proving that two parts of a triangle are congruent to each other, then your proof is gonna end with what? Good. Y'all, if you're proving that two sides are congruent to each other or two angles are congruent to each other, then your proof is gonna end with CPCTC, okay? Y'all, before you can prove that either two sides or two angles are congruent to each other via CPCTC, what do you have to prove first? That your two triangles are what? Good, you have to prove that your two triangles are congruent first. All right, so let's get it. But Ms. Gross, we have no blanks today. It's not filling the blank today. Nope, okay? We're gonna write the whole thing from scratch ourselves. Y'all, remember, statements on this side, reasons on that side. I don't know why mine didn't pop up, but we get the gist, okay? Now, for my people who weren't here yesterday, where you see the word given, that always gives you your first 2 to 3 statements, okay? That's where you pull it from. So our first set given says, line segment AC bisects angle BCD. Okay, our second given is line segment AC bisects angle BAD. Okay, y'all, and we're trying to prove that triangle ACD is congruent to triangle ACB. First things first, what's our first statement? Good. Side AC bisects angle BCD. Y'all, what is our reason? Good, it is given. Okay, it's given. Y'all, what do you think happens if side AC bisects angle BCD? What is it going to do to angle C? It's going to cut it into what? 2 equal what? Now triangles, 2 equal what? Y'all, BCD is an angle. It'll cut angle BCD into 2 equal what? Good angle, okay? Y'all, what's our second statement? Y'all can go ahead and mark it. Okay. Up. Y'all, we skipped it. Hold on. My thing is not marking. Y'all look, when it marks on your slides, you'll notice when you mark angles that are right on the same side, sometimes one of your arc marks is going to be pushed out further back than the other one. Okay. And it's just but it still means that they're congruent because they have the same number of arcs. Some resources just do that, okay? But it still means they're congruent. Okay, so our second statement is, Ms. Groves, what happens to AC bisects BAD? Y'all, I just set these slides up a little differently. So we're looking at angle BCD, okay? Y'all look, how do we know angle BCD? I said BCA, oh goodness. Y'all, angle BCA is congruent to DCA. How do we know that? Definition of what? Y'all look. What type of bisector? Good. Your reason would be definition of an angle bisector, okay? Y'all, an angle bisector is just gonna take an angle and cut it into two equal pieces, okay? Y'all, what's our third statement? Good. Oh, it just came up late. Okay. Good. Your third statement is side AC bisects angle. Y'all look, BAD, okay? And somebody already said your reason is that it's given, okay? Y'all, it's no mystery. What is statement number 4? Look at your pattern. We haven't got that far yet. What's our next statement? Y'all look at the pattern right here. If side AC bisects angle BCD and it created angle BCA and DCA, what happens when side AC pretty much bisects angle A or angle BAD? It cuts it into what? Two equal pieces. Okay, y'all, I'm gonna pre-mark it so you can see it. My slide will mark it for you in a sec. Okay, look, what that says is that bisector splits that angle in half and those two angles are congruent to each other. So what's our fourth statement? What's the name of that angle? Remember the name of the letter of the angle has to be in the middle. Good, CAB. Okay, I just said them backwards. Miss Girls, can I still call it CAB? Yes, y'all, that's the same angle right there. Just named in a different way, okay? Y'all, how do y'all know that these two angles are congruent to each other? What's your reason? What type of bisect, angle or segment? Good, definition of angle bisector. Y'all, the reason you know it's angle bisector, because AC is bisecting angle BDC and AC is bisecting angle BAD, okay? That's how you know it's angle bisector, okay? Y'all look, what else is inferred on this diagram that we have not marked? Look at your diagram. Good, your middle line, what's the name of your middle line? Okay. So your fifth statement is, what's your reason? Y'all, what you see, where you see midpoint? Y'all, what does midpoint mean? Wait, stop. What does midpoint mean? The midpoint cuts the line segment into how many equal pieces? Y'all, if it was midpoint, it would say midpoint somewhere up here. It doesn't say midpoint. Y'all look, y'all told me AC is congruent to AC. How do you know that those two lines are congruent to each other? Yeah. Good, it's the reflexive property. Y'all be careful. The reflexive property tells us that line AC is congruent to line AC. Okay. Y'all, what's our very last statement? The triangle ACD is congruent to triangle ACB. Okay. By what? Good. Look. Angle, side, angle. Let me write it. angle, side, angle, angle, side, angle, okay? That's it in a nutshell, okay? That's just reinforcing what we did yesterday. All right. Let's do another one, okay? Y'all look, this time we're trying to prove what? This time we're trying to prove what? Good. Y'all, what do we have to do first in order to prove that side ED is congruent and corresponds to side DA? We have to prove that the two triangles are what first? We have to prove that the two triangles are congruent. Hey, tell me what your first statement is. Good. Your first statement is C is the midpoint of line segment AD and EB. What is your reason? It's given, okay? Y'all look at your diagram and mark, okay? It says C is the midpoint of line AD. Y'all look, if C is the midpoint of line AD, what do we know to be true about the distance from D to C and A to C? Y'all, my question is, if C is the midpoint of line segment AD, what do we know to be true about the distance from D to C and A to C? Good, it's congruent because that's the midpoint. Y'all go ahead and mark it. Okay, y'all look, they also tell us that C is the midpoint of line segment EB. So what do we know about the distance from E to C and B to C? Good, they are also congruent. Okay, y'all, we're just marking. We'll go back and list the reasons in just a second, okay? Y'all, what else do you notice about the triangle that's not marked? Good, you also have a set of vertical angles, okay? Y'all, now your triangle is all marked for you, so it should be a bit easier for you to identify the rest of your statement, okay? Y'all, somebody tell me what you feel like statement number 2 could potentially be. Uh-huh. Uh-huh. Okay, EC is congruent to BC. Somebody tell me something else that could have potentially been that. Because y'all, sometimes you may write it in a slightly different order than somebody else, but as long as you have your corresponding parts lined up and you have your reason lined up correctly, your proof is still correct. So what I'm saying is sometimes people may have their statements and reasons in different orders, okay? So she said EC is congruent to BC. Yeah, I know that's not the next one for me. So what else do y'all notice? CA is congruent and corresponds to what? Yeah, that's what I got. Okay. AC is congruent to CD. Ms. Groves, what if I call this CA and DC? Y'all, it's the same segments. I just wrote it backwards. Okay. Y'all don't get out of whack. What is your reason? Y'all look at your given. It's a key word in there that helps you figure it. Good. Your reason is definition of a midpoint. Okay. Y'all, again, if you see the word midpoint in information is given, then you know that somewhere one or two of your reasons is going to be definition of a midpoint. Okay. Y'all tell me what y'all think your next statement is. Somebody already said it. Uh-huh. Okay. She said first, line segment EC is congruent and corresponds to CB. Y'all, what would still be your reason? Definition of a midpoint, okay? Y'all, what I was trying to explain a second ago is that when some of y'all, if y'all were to write this proof, some of y'all would put statement number 3 as your statement number 2. Instead, it's still correct because you're still identifying your corresponding parts in your statements and you're still giving the correct reason, okay? All right, what's the last, or not the last, not to the last yet. What's the next statement is what I should be saying. Huh?
I think
Yo, look what else we have marked. Look, we marked the names, our 2 sets of congruent corresponding sides. What didn't we mark? the vertical angle, okay? So what do you want to name those two vertical angles? Y'all, again, when y'all click the side, when I click the side, my name may be different. Okay, it may be backwards, but still correct, as long as you name it with the vertex in the middle. Good, angle ACB is congruent to angle what? It's up here, E. Look, she said ACB. Y'all be careful, look at how you named it. Not ECD. Good, DCE. Miss Grubbs, why? Look, she called it ACB. Y'all look at how the sides are marked. Okay, you go from 1 tick mark to the angle to 2 tick marks. So you have to follow the same pattern. That's why the second angle has to be DCE, because she called the first one ACB. Let me see what I call mine. I called it ECD and BCD, okay? And y'all know the reason is because they are vertical angles. Your classmate already said that, okay? Woo, we almost there. Y'all look, the fifth statement is what? We have to prove that the two triangles are what to each other? Okay, y'all, let me click it because I don't remember what I named the triangle. Okay, so I said triangle ECD is congruent to triangle BCA. Miss Grubbs, what if I wanted to name it another way? It's fine, just as long as your corresponding parts line up. Say it again, please. Same thing as what? So y'all look, how are those two triangles congruent to each other? Good, side angle side. Look. Y'all, if you know that you are still not making the connection by looking at this, mark your figure. Side, angle, side, side, angle, side. Okay? Side, angle, side. Whew. Our very last statement is always what we're trying to prove. So statement 6 is going to be good. We know that side ED is congruent and corresponds to BA because of CPCTC. Okay. Woo, Miss Grubbs, that's a lot. I know. Y'all, again, we were just looking at the diagram and thinking about in our heads, or really sometimes speaking out loud, how we identified our corresponding angles and corresponding sides. Y'all, all we're doing now is just listing it and writing it down. That's it. That's all a proof is. You're writing down the steps of how you prove two triangles are congruent to each other, or two sides are congruent to each other. Woo. Now, you own the recording. Your parents gonna be looking at this like, what's she saying? Y'all know they go check sometime. All right, so let's look. Let's see if we can partially zoom through this one. Okay, Miss Grubbs, what does this symbol right here mean? Y'all, the upside T means perpendicular bisector. Okay, that upside down T means perpendicular bisector. And what that perpendicular bisector is going to create is some 90-degree angle. Okay, so let's walk through this one. What is going to be our very first statement? Good. Point B bisects side AC. Okay, what's your reason? It is given. Okay, y'all look, what happens when point D bisects side AC? Good, it just takes that segment and splits it into two equal parts. Okay, so if that's the case, what do y'all think your next statement is going to be, statement number 2? Look, what happened when point D split segment AC, when it bisected AC, it split it into two equal what? Not two equal triangles. Good. That's your next statement. Y'all, since point D bisected side AC, it cut side AC into two equal parts, not two equal triangles. It's already two separate triangles. Okay. It just split that segment into two equal parts. So your next statement should be that side segment AB is congruent to segment DC. What is your reason? Good. Definition of a segment bisector. Okay, that's it. Definition of a segment bisector. All right, y'all don't overthink, but look at your diagram and see, okay? Or look at what's given and see. Y'all, what do you think your third statement is gonna be? The BD is perpendicular to AC, okay? Y'all remember, I told, and what's your reason? I'm trying to move too fast. But it's given, okay? AD is perpendicular to AC. You just got it from right here. And that information is given. Y'all remember, I told you a perpendicular bisector creates, okay? Excuse me. Let me see if it's gonna pop up. Popped up number 4. It's gonna create 2 right angles, okay? Right here. Come on, what? Okay, right here and right here, okay? That's what a perpendicular bisector does. It creates 2 right angles, okay? Y'all look. We got right angle ADB and right angle CDB, okay? That's gonna be our next statement, okay? That's our next statement. Because that bisector just created those 2 right angles, okay? Y'all, I'm gonna erase what I marked now because it should pop up now. Okay, and your reason is just because those are perpendicular lines, okay? Your reason is just because those are perpendicular lines. Ms. Gross, we didn't have that as one of the reasons. I know. We'll have to go back and add it, okay? Definition of perpendicular line. Come on, pop up on the slide. Then right angle's really not gonna pop up. Y'all, reason number 5 goes back to reason number 4. Y'all, how do we know that angle ADB is congruent to angle CDB? Look, how do we know that these 2 angles are congruent to each other? How do we know that ADB is congruent to CDB? What type of angles are they? Right. Good. So your reason is because right angles are congruent to each other. All right. Y'all, we missing one thing from that diagram that's inferred, but it's not marked. What we missing? What's not marked that we should mark? Good, okay. So look, if we know we should mark line segment BD, what would be our 6th statement? Good. BD is congruent to BD. What's our reason? Not midpoint. With a reflexive property. Y'all, if 2 triangles or 2 figures share the same side, be careful. It has absolutely nothing to do with the midpoint. That is the reflexive property. The midpoint is always going to take a line segment and cut it in half. Okay. Reflexive property tells you that that's the same line. It's just in 2 different triangles. Okay. Now it wants to mark my right triangle way 5,000 hours late. Okay. Now, y'all look, there was a question very similar to this on the quiz. And some of you marked HL for this. Y'all, is it possible for these 2 triangles to be congruent to each other via HL based on the way that these 2 triangles are marked? No, because you do not know anything about the hypotenuse. Y'all, there is nothing that we have written in our statement so far, or nothing that was given to us in the given information that implies that these 2 triangles are congruent. But Ms. Grubb, can't we just say that AB is congruent to CD? No, because it's not implied and it's not given, okay? Y'all look, how are these two triangles, right triangles specifically, how are they congruent to each other if it's not HL? Good, side angle side. Side angle side, side angle side, okay? So that's your seventh. Y'all, this is a long one, okay? Y'all really, if I had given you a proof like that, I would not have split statement number 4 and number 5. I would have condensed them to create one statement, because that's a lot to separate. Okay? And somebody said the reason is that these two triangles are congruent to each other via side angle side. I'll carry y'all to the end. What's our last and final statement? Good. Good. And we were able to prove that side AB is congruent to CB via CPCTC. Okay? Y'all questions? Y'all got the last one? All right.